How do you calculate the modulation index for AM and FM? Imagine tuning into your favorite radio station and wondering how the sound quality is maintained or how the signal's strength is controlled. Today, we're going to explore how engineers measure the extent of signal variation in two common types of analog modulation: amplitude modulation and frequency modulation. These measurements are called the modulation indices, and they are essential for designing clear and efficient communication systems. Let's start with amplitude modulation, which is when the strength of the carrier wave changes according to the information signal. The modulation index here tells us how much the amplitude of the carrier wave is varied. To find it, you take the peak amplitude of the modulating signal, which is the information you want to send, and divide it by the peak amplitude of the carrier wave itself. Think of it like comparing the loudness of your voice to the overall volume of a speaker. If the maximum amplitude of the modulating signal is the same as the carrier's maximum amplitude, then the modulation index is 1, meaning 100% modulation. If the modulating signal's peak is less, the index is less than 1, indicating less variation. But if the modulating signal's peak exceeds the carrier's, the index becomes greater than 1, leading to overmodulation, which causes distortion. In practical terms, you can also measure the modulation index by looking at the envelope of the modulated wave with an oscilloscope. You measure the highest point of the envelope, called Vmax, and the lowest point, called Vmin. The difference between these two divided by their sum gives you the modulation index. So it looks like this. Take Vmax minus Vmin, then divide that by Vmax plus Vmin. This method is handy when you have a waveform to analyze directly. Now let's switch gears to frequency modulation, where the frequency of the carrier wave varies with the modulating signal. Here, the modulation index is the ratio of the maximum frequency deviation caused by the modulating signal to the frequency of that modulating signal itself. The maximum frequency deviation, called delta F, is how far the carrier frequency shifts from its normal value. The modulating frequency, FM, is the highest frequency component in your information signal. To find the index, you divide delta F by FM. Think of it as measuring how much the pitch of a musical note changes relative to the original note. If the frequency deviation is small compared to the modulating frequency, the modulation is narrowband, meaning less bandwidth and simpler processing. But if the deviation is large, the bandwidth increases, which can improve noise immunity but requires more spectrum space. In summary, for amplitude modulation, the modulation index is the ratio of the peak modulating amplitude to the peak carrier amplitude. For frequency modulation, it is the ratio of the peak frequency deviation to the modulating frequency. These calculations help engineers control signal quality, avoid distortion, and optimize bandwidth. Whether you're working on radio, television, or wireless communication, understanding these indices is key to making sure your signals are clear and effective.